On the early morning of July 30th, catastrophic landslides claimed 226 lives and more than 200 people missing as per official data after 1 week. This marks the worst natural disaster ever in Kerala. Despite facing annual flash floods and landslides since the 2018 flood, the public still lacks access to precision weather alerts. Information on hourly precipitation, floods, and landslide impacts with specific evacuation timings and locations are still unavailable. Instead, what we witness is the political blame gaming soon after every natural disaster. If the science and technology do not benefit the public, then what's the purpose of research and development? Welcome to a new episode of Asianet News Science Talk, and let's explore how to adapt to the extreme climatic conditions we are facing now with our eminent guest today, Professor Jagdish Krishnaswamy. He is the Dean of the School of Environment and Sustainability, Indian Institute of Human Settlements, Bengaluru. A pioneer in eco-hydrology in India, Professor Krishnaswamy's work on conservation science and planning contributed to the nomination of the Western Ghats Biodiversity Hotspot as a UNESCO World Heritage Site. His mapping of priority sites in the Western Ghats was also instrumental for the Madhav Gadgil report. As a lead author of the IPCC Special Report on Land and Climate, he has extensively studied the impact of extreme rain and warming on ecosystems across India. He joins us now from Bengaluru. Professor Krishnaswamy, a warm welcome to Asianet News, and we appreciate your prompt response to accept our request for interview when most of the scientists in our state are reluctant to speak to the media for the time. Maybe due to the blame game between the center and state. So thank you very much for joining us.
A pleasure and a privilege.
Thank you.
And I'm sure that those scientists must have had their reasons for not coming. But in any case, I'm very. I think this is a very important topic. So thanks for giving this opportunity to share my thoughts on this.
Appreciate your stance, sir. Then you wrote an article in Mint following the 2018 flood in our state, Kerala. What's your take on the recent catastrophic landslides on the early morning of July 30th in Wayanad?
Yeah, so what happened is, of course, a tragic disaster. And the first task is, of course, to do relief and rehabilitation of the affected people. So that's the first priority. But following that, we need to really act quickly on measures that we can take to prevent or minimize such devastation and such tragic loss of life, infrastructure, and property in the future, because this type of event is likely to happen again. There are some issues that we need to learn from based on both 2018 as well as this event, not just from Kerala but other parts of the country. So climate change is a reality, and extreme rain events are going to be happening. So we really need to change the way in which we have to, in terms of adaptation, but also in terms of generating the right type of knowledge and data for effective and timely action at local and regional scales. So that is one important, I think, issue that we need to all work together towards. How do we build the capacity in terms of knowledge and data at local scales so that early warning systems can be set up? And there were some insights from the Kerala floods in 2018 that you have referred to, and some of them are still relevant for this particular event as well.
So, what are those relevant facts, sir?
So one is, of course, that apart from just rain gauges, we need these stream gauges and soil moisture sensors in the remote locations. So we have to take note of the fact that both in the Nilgiris, where I have a long-term site for over a decade, as well as in Wayanad, sometimes the landslide, the source, the origin is often in a remote forested area where there may not be any human habitation. And so because the type of rains that we are now seeing and the very distinctive hydrological conditions that we have, hydrogeological as well as soil, as well as hydrologic conditions that we have in some parts of the Western Ghats, it makes these sites very vulnerable, susceptible to these extreme rain events. So we now know that subsurface flow is a very important part of the hydrology of some parts of the Western Ghats. So you have things like pipe flow, you have large macropores below the surface of the soil, and these get triggered in a very non-linear way whenever the rain is very intense. And so you can actually have large volumes of water flowing below the surface in these subsurface flow channels that can lead to rapid flooding downstream. So the human activities, infrastructure, and how we plan our settlements and land use, that is very important in the downstream area. But in the upstream area, we really need a network of sensors, preferably if they are there's telemetry, so that the data and evidence on soil moisture buildup, on stream flow buildup, can reach the, say, district headquarters on a dashboard on almost on an hourly basis. So we need to set up those type of systems in all our vulnerable catchments, not just in Wayanad, but in other parts of Kerala and other parts of the Western Ghats and the Himalayas as well. So this is something, climate change related extreme weather events, these are going to happen again. So we have to be prepared with the best possible knowledge and data in order to develop local forecasting ability. So, some of the climate models are very coarse. And, in terms of trying to predict what is going to happen 50, 70, or 100 years, yes, that is of some use, definitely. But right now, we need to develop our own models to be able to forecast such disasters, hazards at a local scale, which means that semi-empirical models, data-based models, like we have used in the past in some places with a lot of success, may be the way out, along with, of course, collaboration across both civil society organizations and government agencies. Center and state both have to collaborate together, and all our scientists who have any ability to contribute to this topic should work together so that we can actually find a solution for this.
But what we experience is the monopoly of weather alerts by various central agencies, that is IMD and CMC to issue rainfall alerts, then CWC to issue flood alerts, and GSI to issue landslide alerts. So the net result is that public is not getting timely, exclusively impact based weather alerts. So what must be done to streamline all these central agencies by the central government, or how should the state government address this problem?
So I think that having any institution or a group of organizations or any one organization having monopoly on any kind of knowledge or data may not be desirable under such circumstances. As long as we can ensure that the data being collected is with using the right instrument and it has been looked at rigorously, we should be welcoming data and evidence from across institutions, both at the local level, state level, regional, and center, as well as from civil society organizations. So, for example, throughout the Western Ghats, we used to have planters, whether it's coffee planters or tea planters or other types of plantations, they used to maintain their own rain gauges, and those are all valuable records. Some of us who are not in the government, we have been maintaining long-term observatories, hydrologic observatories in the Western Ghats, where we have rain gauges at very remote locations, some of which have to be approached, after a few hours of trekking and so on. And with improvements in short-term weather forecasts, we will be able to, raise the level of our early warning systems in the future. But till then, I think that we have to rely on whatever head start we can get. Even if we get a few hours of head start, a half a day of head start in terms of some buildup of moisture, which is going to be give us the opportunity to either evacuate people or move people out of harm's way. These are things that we need to now think about. And the other aspect is that this collaboration that we need to have, we all have to shed our egos in terms of our institutional mandate and so on, because this is a disaster situation. And unless we all collaborate and cooperate together across government agencies, state, center, and civil society organizations, because civil society organizations now have the capability also to monitor data and information. So, for example, I have worked in the non-governmental sector, and I have done hydrologic research and maintained long-term sites with and generated very good quality data. So I'm sure that any government agency will be able to also appreciate that, and we all need to work together to sharing data. We now have to find some ways for all this data to reach a dashboard in an organized manner.
Even if we have resources locally, these data will not be taken up seriously by the authorities. They take the data only from IMD or CWC or GSI.
I agree that that is a big barrier, and so we need to find some
So how you
solution for that.
scientists solve these barriers?
Yeah. So, for example, there can be a common dashboard for all such data to contribute. So, if you have a map of Wayanad showing all the instrumentation which is collecting real-time data, whether it's on soil moisture, whether it's on the first order and second order streams of water levels, as well as from rain gauges, if all this data can come to a portal, which is available to both the government agencies as well as to district officials and civil society. And we all agree that this data from all sources is going to be useful for making some sort of forecast with uncertainty. There will always be some uncertainty associated, but it's better. So basically, we have to be safe than sorry, which means that, once in a while, such forecasts and predictions may not lead to a disaster, but at least we would have, when it does happen, we would have kept people away from harm. So I think that this is the approach that we have to take, because this type of tragic loss of life and property cannot be allowed to happen again.
Your work on the conservation science led to the nomination of Western Ghats Biodiversity Hotspot as UNESCO World Heritage Site. So, what are your key findings regarding the Western Ghats, and how do they compare with other ecosystems across India and abroad?
So the Western Ghats is a very unique biodiversity hotspot. It's one of the most densely populated biodiversity hotspots as well. So, and that makes it different from other biodiversity hotspots around the world. And secondly, apart from the natural and semi-natural ecosystems like the evergreen forests or the deciduous forests or the grasslands, we also have a lot of agro ecosystems in the Western Ghats, which also provide ecological connectivity. So some of them are managed well, some of them not as well as they ought to be. But these agro ecosystems, if they're well managed, whether it's a coffee plantation or other types of plantations, agro ecosystems, they contribute to food security. They provide a lot of medicinal herbs and many other products, honey, so many ecosystem services that people are getting out of these Western Ghats ecosystems, that together, both the natural, semi-natural, as well as the managed ecosystems, together they provide, make the Western Ghats really unique compared to other biodiversity hotspots. So we have to learn how to share space between humans and nature, and that is a huge challenge. Whether it is in Wayanad or anywhere else, we need to ensure that we recognize the hydrological, geological, and ecological conditions. And so sustainable development will have to be designed for that purpose. And with extreme rainfall happening because of climate change, and it's likely to become more frequent in the future, we need to find ways of adapting to this, including the type of livelihoods and economic activities and the type of infrastructure that can be allowed to come up in certain parts of such areas.
When you compare the soil at the hydrological level, is there any peculiarity for Western Ghats?
So in 2017, I was part of a group of hydrologists. We worked together on data from Western Ghats and other parts of the world, where we have a phenomena called subsurface flow channels. So basically, we found a non-linear relationship between the residence time of water um, in the catchment, uh, and it really plummeted very quickly in a non-linear fashion with increase in rainfall intensity. So these subsurface flow channels are able to transfer huge volumes of water into the stream without recharging groundwater necessarily. There's these shallow subsurface flows. They can allow water to reach the stream very quickly. So it's not just about surface runoff, but also rapid subsurface runoff, which is a characteristic of the Western Ghats. And some parts of the Western Ghats, we also have a phenomenon called pipe flow. So these are channels where, which are made in the soil system by roots and other types of subsurface erosion. So when you have tree roots penetrating, these macropores are there. So on one hand, they allow for a lot of the rainwater to infiltrate also, but they also, under very intense rainfall, they can become conduits for very rapid flow. So that is why we feel that semi-empirical models to making predictions about the hydrologic response may be more effective at local scales or regional scales in the Western Ghats, and not physics-based models alone, which may work in other types of situations. So I think that we really need the hydrological community to come together to put together the best ideas and come up with a early warning system that will work for a place like Wayanad. And we should test it out. So hopefully next year, the monsoon, we won't be having such huge rain events or extreme events, but with whatever data that we can gather next year, we can test out some of these models and see how well they're doing and improve them. So we need to really develop this local capacity to be able to make meaningful predictions to enable the district authorities to move people out of harm's way. And then in the slightly longer term, we need to have land use that will be compatible with the, for example, during the monsoon, we may not have people living in some places, and whereas after the monsoon is over, maybe they can go back to those places and get some livelihood and get some opportunities in the non-monsoonal period. So we need to have this type of adaptive management and mobility, quick mobility of people during the early part of the monsoon season. These are some of the things that we probably need to try out in the near future.
So how can we manage the drought like situations also, because in last summer the North Kerala experienced heavy drought like situations also.
So we are going to be seeing droughts in some years, dry conditions in some years, and some very wet conditions in as well, depending on so many factors. Because our monsoonal systems, we have very complex monsoon system is also changing, and with the Arabian Sea warming up, with also the greater ability of a warming atmosphere to hold more moisture, these are all things that we can expect. that we may have both drought and heavy rain coming one after the other. And so we need to have different strategies for different seasons. We'll have to improve our ability to capture and store moisture in the drier years, and then also adapt to very wet rainfall conditions. It's not going to be easy, and there are no easy solutions for this. But we have to try out in a pilot way what might work, because the challenges of on the water side, what type of crops we should be growing, which may be requiring less moisture in the future, what type of activities will help us with using water prudently, carefully during the drier years. These are things that we need to think about, and we'll have to adapt to some of these conditions with changes in our lifestyle as well as land use and our cropping pattern. We also may have to recycle our wastewater from cities and towns, because treated wastewater is going to become a very precious resource that needs to go back as part of our water security solution. We can no longer afford to have large volumes of water being treated, going untreated, because that untreated wastewater cannot be used for many purposes. But certainly some of it treated wastewater can be used for agriculture for sure. And if we really do a good job of treating grey water, it can actually even be used eventually for supplying drinking water. So these things are possible. There is now technology and evidence and knowledge available to do some of these things on the ground.
Your mapping of priority sites in Western Ghats was also instrumental for Madhav Gadgil report. So can you elaborate on this?
Yeah, so I was part of the many people that were consulted for preparing the Madhav Gadgil report on eco-sensitive zones in the Western Ghats. So we provided a lot of the data on the high conservation value sites, including the ones in Wayanad and other parts of Kerala, Tamil Nadu, Karnataka, Maharashtra, Goa, so ecological attributes and hydrological attributes, sometimes they go hand in hand. So some of the very steep, vulnerable slopes in the Western Ghats, they are also biodiversity hotspots within the Western Ghats. So actually we can, when we conserve nature in the Western Ghats, we are maybe also be reducing the vulnerability of the downstream areas from devastation and damage during heavy rain events or other types of issues. Even natural ecosystems can get impacted by such rain events. I have mentioned to you that not just in Wayanad, but also in the upper Nilgiris, which is adjacent to Wayanad, where we have a long-term site. Even a Shola forest was devastated by a landslide, even though it was in an uninhabited area. So even natural ecosystems, well-forested hill slopes are also not able to sometimes withstand the fury of these high rainfall events, where we are having several hundred coming in a couple of days. Sometimes we have very high rain falling in a few hours, a few hundred following in a few hours. These are all, and especially when the soil is already wet after a few days of rainfall, these are conditions where even so-called natural ecosystems can also crumble. And we have seen examples of that. So we should be very careful in attributing everything only to land use and land cover change. The type of climate extremes that we are now facing may even stretch the limits of tolerance of even some of our so-called pristine ecosystems as well.
In this context, can I ask your response on many environmentalists claim that excessive or illegal mining activities in Western Ghats area are causing these continued landslides?
So I would not say that every landslide can be attributed to any one factor. So it depends on the site. So there are landslides which have emerged where the source areas have been in forested valleys or forested hill slopes. So that means that attribution cannot be made to activities like quarrying and so on. But if you can imagine that in some other area where you have destabilized a hill slope because of quarrying or mining and weakened the geology of that hillside, certainly when that interacts with heavy rain, you're going to be having a greater chance of failure. So again, it is we cannot say that everywhere the cause for landslides is because of one factor or the other. We have to, as I was mentioning, that we have to make the attribution to land use and land cover change and to climate extreme in a slightly more nuanced manner, which means that we have to be very careful about attributing everything to one factor alone, and because that is not going to help us find the solution.
Another criticism is that sediments are not being timely removed from or flushed out from dams or reservoirs, which results the limitation of the storage of excess rainwater during the heavy rainfalls. So, what measures are needed to maintain the efficiency of the storage levels of dams?
So over the past few decades, now there is data and evidence to show that the way that we have been managing our reservoirs and dams, we may have to change that because of what we have learned. So for example, flushing out sediments from time to time using lower level sluices. Wherever there is a dam which have lower level sluices, then we do have to think of ways of flushing out the sediment. It may not always be possible. In some other cases, we also may have to think about not always wanting to maximize the storage in our reservoirs. Also, to, in some sense, release the water with good forecasting models or even upstream sensors which can, pick up the buildup of soil moisture in the upper catchment. In which case, then we can take, in some sense, a proactive measure of starting to release the water, so that whenever there is an extreme rain event in the upper catchment, the reservoir will have increased capacity to hold that water, and so that we don't have to suddenly open all the gates of the dam at the last minute, and that led to a lot of problems in the past in many parts of the country, not just in Kerala. So I think that this we all now know that the hydrology is a very dynamic system. It has changed over time. We cannot think of stationarity as a principle and talk about a 50-year flood or a 100-year flood. Those are all now the old textbook cases. But now we are these types of events are going to happen every 3 to 4 years sometimes, and therefore we need to change our management of reservoirs and dams. And this will also help us maintain ecological flow in our rivers downstream, because water flowing and sediment flowing through the system on a regular basis from time to time, that is the way in which we can prevent buildup of sediment in our reservoirs. Now, whichever dams don't have lower level sluices, we may have to think of some types of flushing operations that can be done. If you are lucky enough to have a moderate to slightly higher flood event emerging, you can use that opportunity to flush some of the sediment downstream. But it also requires such releases of water from dams just before just before the monsoon or in the early part of the monsoon will also have to be connected to early warning systems and arrangements downstream, so that we don't have any such problems with harming people. Because we have had cases where in both Himalayas and elsewhere, where suddenly dams have released water and it has killed a lot of people and the livestock. So dams, if they are not managed properly, can also become part of the problem, and they're not just part of the solution sometimes. So we now have to think about how to manage our dams and reservoirs in an alternative way, given the realities of extreme rain events, and also the need for maintaining ecological flow. Because the earlier view that rivers carrying water all the way to the sea, it's a waste of water. We know that is not the case. The water and sediments that reach the coastal areas, they help rejuvenate the coastal fisheries and maintain important ecosystems in the marine side as well. So we need to find ways of sharing water between different types of uses, and so managing our reservoirs in a different way through pilot experiments and then learning from that and then going forward. I think that is the need of the hour.
That is, during the pre-monsoon time, we need to flush out the sediments from the dam in a proper way.
Well, it may not always be, it's not easy to do that. You do require, so as I said, it depends on the design of the dam, whether they have lower level sluices or not, what is the shape of the reservoir. So there are some reservoirs where sediment flushing is going to be a little easier than in other reservoirs. So it is complicated, but we need to now think together about in which reservoirs we can actually perform such operations. And in other cases, we may have to utilize the slightly moderate to heavy floods that may not be devastating, but they can be used for flushing sediments from the reservoir. So we need to think of all these possible ways of reducing this issue.
You developed India's first long-term urban ecological observatory in India. So what is its scope, objective, and advantages so far?
So, we've, unlike many other countries, we have not actually been very successful in maintaining instrumented catchments or long-term observatories for which in some other countries and some other parts of the world have been collecting valuable data for many decades, sometimes even over 100 years. So we have come very recently to this issue of maintaining ecological observatories. The Ministry of Environment, Forest and Climate Change started one initiative. And then a few other institutions have maintained some long-term or medium-term sites. But apart from the rural, wild, semi-wild ecosystems, we also need to look at urban ecosystems and urban areas as places where ecology, hydrology, environment is also going to be very important in terms of data collection as well as informing policy and management. So there are a few urban ecological observatories. So for example, in Baltimore in the USA, in Phoenix in Arizona in the USA, a few other places. But for a mega city like Bengaluru, this is the first such initiative. And it's an idea that we need to really build on. It basically means that we have to track human nature and human-human interactions over space and time, using all types of data gathering devices, not just instrumentation and sensors, but also remote sensing, citizen science, and also find solutions for many urban problems, whether it is related to water security or climate security or ecological and biodiversity conservation. Because urban areas are going to be very important in terms of our sustainable transformations in the future. Because 50% of Indians will soon be living in some form of urbanized space. The sooner we have the ability to use evidence and data for managing these complex changes in the environment, and also to act as early warnings systems, sentinel sites. That is the purpose of the long-term urban ecological observatory that we are trying to set up in Bengaluru. And it is going to hopefully involve all types of civil society as well as other stakeholders to benefit from it, because the data that comes from such long-term observatories should be helping us manage our cities better in the future.
Don't we need rural observatories too?
Definitely. I think that, for example, if we have long-term data on in agro ecosystems, and to track how, because of changes in cropping pattern, because of changes in how farmers are responding to challenges, how that has changed over time. If we had, say, 30, 40 years of data from different sites, systematically monitored and measured with the participation of farmers, by now we would have had a wealth of data to understand some of the long-term dynamics. and we can capture certain types of tipping points, because the plummeting of groundwater levels beyond sustainable levels, which happened in some parts of the country, we could have captured that trend much earlier and come up with some form of management intervention or policy intervention. So eventually it will depend on policy and governance, but policy and governance requires good knowledge and very good high quality data, and that should be the purpose of any observatory.
What is your advice to research aspirants in hydrology and environment science?
So I feel that many of the so for example, some of us who have been working in hydrology, we have worked in the field. We have established instrumented sites in remote areas. We do a lot of field work. We take measurements of stream flow, soil moisture, transpiration, using primary measurements, and we are familiar with the soil or geological conditions because of experience of going into the field. Now, we also have hydrologists who are extremely very good in modeling using physics based models or mechanistic models. I think that we need to combine strengths, because field hydrologists and modelers really need to work together. And we also need to think about semi empirical models, because they might be much more effective in a localized situation, for example, such as in Wayanad. And so that we can develop these decentralized early warning systems. So instead of depending only on a few agencies, we need to develop local capacity to deal with it. And I think that we have very good hydrologists in India. We have very good geologists in the country. We have good ecologists, and we have good civil engineers. We really need to come together to find effective solutions for uh, for managing vulnerable areas safely in the future.
There is a research paper by you on role of rainstorm intensity underestimated by data derived flood models. So this
Yes,
supports your advice also.
if you see that graph on the y-axis, there is the what is known as the residence time of water in the catchment, and on the x-axis is the rainfall intensity. And you can see that that's a 15-minute rainfall intensity. You can see that as the rainfall intensity goes beyond a point, you see such a non-linear decline in the ability of the catchment to hold water, and that is because these are all sites with rapid subsurface flow channels. So, which is a big part of the Western Ghats, including in places like Wayanad, Upper Nilgiris, maybe even Uttar Kannada. There are parts of the Western Ghats where these subsurface flow channels are an important part of this of the hydrologic response, and therefore we really need to think about uh, of using such insights that we have had from field hydrologists and data and database modeling to contribute to effective forecasts at scale. It should be relevant at the scale. So while the core scale climate models, which tell us about what might happen to the monsoon 30, 40, 50, 60 or 70 years from now are going to be very useful for a very different purpose. But right now we need to enhance our ability to make reasonable forecasts which the district administration can use. And so that is where I think that we have a sort of a gap, and even other folks, scientists like Raghu Murtugade and other folks have also been saying that climate models which IPCC uses and so on, they are useful, but right now we need to develop these decentralized local forecasting ability, and that will only come through the combination of high resolution field field sensors linked to semi-empirical models, and hopefully as our short-term rainfall forecasts improve in ability, then we can also start using that as well. So we need a comprehensive approach to developing a high quality but pragmatic early warning system that will work for situations like this.
You were the lead author of the IPCC special report on land and climate. And for this, you extensively studied the ecosystems across India. Can you share the experiences?
Yeah, it was a very valuable experience for me to contribute to an IPCC report. I also realized that as part of that particular special report, that land, productive land is becoming an increasingly scarce and precious resource. And due to climate change, productive land is going to be exposed to all sorts of hazards. So, to maintain the productivity of land and also the types of uses for which there is a lot of competition for land, whether it's for food security, whether it is for biodiversity conservation, whether it is to set up a large solar farm, or to have townships and infrastructure, tourism. These are all competing uses of land, and therefore productive land, maintaining the productivity of land through the next few decades, based on these different types of drivers, that's going to be really tough. We really need to think about land as a precious and finite resource, and degrading the land is not an option for us. We should actually be finding ways to restore our ecosystems, and also to have sustainable transformations. We have very adaptive ways of earning livelihood and developing local economy, which does not which cannot be wiped out overnight because of the type of disasters that have happened. So we need to think out of the box, and this is not going to be easy. The solutions are going to vary from district to district, place to place, but at least we should start moving in the right direction.
On a personal level, after earning your B.Tech in civil engineering from IIT Mumbai, you went to US for pursuing MS in statistics and decision sciences and a PhD in environmental science. What inspired you to shift your focus to environmental science and hydrologic science?
Yeah,
Also,
first of
could you
all,
elaborate on decision
yes,
sciences, which is
yes, I
relatively
will. I will.
unheard of in
Yeah.
our country?
So for that, just to start, when I was growing up in Delhi, I was lucky enough, even when I was in school, to be exposed uh, to natural history and to environmental issues. When we had a voluntary organization called Kalparvriksha, composed of school and college going kids, and we were able to share, learn from each other, go on hikes and treks, and even went to the Himalayas, and also environmental issues in Delhi and other parts. So that awareness was there, and so there was always this interest in ecology, environment, and natural history. So, and BTech in civil engineering, you do learn quite a bit about fluid mechanics and reservoirs and dams. So it is not completely disconnected from water systems. We also had a very active wildlife and mountaineering club in IIT Bombay those days. So that also really helped sustain the interest. And then moving forward, the degree that I did at Duke University, it was a joint degree. That means you could get a master's in statistics and decision sciences with your PhD in one of three participating departments. And the Department of Environment is one of the departments which had this arrangement with the statistics department. And so I got my master's in statistics and decision sciences and my PhD in environment science, where I focused on soil and hydrologic science together. So it was a joint degree. And the reason for why statistics and decision sciences is so important in the environmental field is that we have a lot of time series data to deal with, and also Bayesian approaches to analyzing data, analyzing also geospatial data. All of this you learn in your statistics, and decisions have to be made with uncertainty. So you use quantitative data, quantitative modeling to help decision makers take decisions on many things, whether it's when to release water from a reservoir, or when to take certain actions, certain precautions, because there are always benefits and losses from taking certain decisions. So you need the best possible knowledge and data, but you also know that there's uncertainty associated with that, and so that is basically what goes into this decision sciences part of the masters in statistics. And then, of course, the PhD in soil and hydrologic science was very just added to that. So together, all of this has enabled me to uh, to um, to come back and contribute something to both the science and the practice of environment and sustainability science in the country.
Can I ask you a curious question? That is,
Yeah.
we on a personal level in our lives also we deal with many uncertainties. So, is this course helpful in facing such situations also?
I think that real life also teaches us a lot of lessons. And when you have scientific training and about uncertainty and decision sciences, but more important, I feel, is the uncertainty surrounding many decisions that we have to take. Uh, in our personal lives as well as professional lives, and I think that or in running a company, or whether it's running an institution, we all have to take decisions with some uncertainty, and not taking any decision is also not an option. So I think that all of this of the theoretical knowledge and but combined with practical knowledge from real life situation, that's what I think helps us with cope with such issues in our own lives and in our own organizations.
Is there any institute in India offering such courses? I'm
I
hearing,
think that we have very good statisticians in the country. We have produced some of the best
but this
statisticians in the
discipline,
world.
but this discipline, particular
And for
discipline.
decision sciences, I think that is where we are lacking a little bit. How do we translate quantitative data, statistical data, um, and models, outputs from models, into decision making on a day-to-day operational basis? um, for different types of systems. I think that the private sector probably uses a lot more of AI and other already to make decisions on marketing, on going forward and all. I think we need to learn from the way in which certain private agencies, corporate sector has started using data in a way to for fostering their business and their market reach and so on. We also need such types of systems uh, to take decisions, helping take decisions in our environmental sector also, whether it's in agriculture, forestry, wildlife management. We definitely need to invest in this type of decision sciences.
Thank you very much, Professor, for sharing your experiences and vast knowledge with us. And we wish you continued success in all your ongoing projects and in the future projects also.
Thank you. Thank you for the pleasure and privilege of giving me such an audience, and the thoughtfulness with which you have invited me and many other people who can contribute to finding solutions for our the challenges that we are facing. Thank you once again.